Hello and welcome to section 12.2. Here are the answers for 12.1. We talked about polyhedron. And today what we're going to do is talk about prisms and cylinders. We're going to find their surface area. So things that you'd normally think of what geometry actually is, shapes. So first of all, prism is a polyhedron with two congruent faces called bases that lie in parallel planes. The other faces are called the lateral faces. And then you have lateral edges. There's two different types of things. There's called the surface area, which is all the faces, and there's lateral area. Keep in mind this right here, lateral area is only the sum of the lateral faces. And again, you may have to rotate or tilt the shapes on their sides. They might not always be standing upright, so keep that in mind. And if you were to cut it out, it makes a net. You don't really have to worry about that, but if for example, a net of a cube, you may have seen this, is where you unfold it and it looks like that. Like this would be like a net of a cube. So yeah, that's what this vocab word down here is referring to. Okay, so that's all the technicalities. What we're going to do is we're just going to add up some sides or some area of the faces and the, yeah. Okay, so find the surface area of a rectangular prism with height 2, length 5, width 6. We're going to draw a picture here of a rectangular prism. So that means the base is a rectangle. It's not going to be the best drawing here, but bear with me. Okay, something like that. Okay, so with a rectangular prism, we just have 6 sides that you just have to add up. So the height is 2, the length is 5, and the width is 6. Okay, so what I see on the bottom is 6 times 30 is the base, so I have 2 of those, the bottom and the top. The left-hand side is 6 by 2, so that's 12. And then the front and the back is 2 by 5, so that's 10. And there's 2 of those. So you're just going to add up those shapes, or the area of those shapes. And there you go. So you're just taking area formulas and just doing a lot of those. Right prism, the height of a right prism is the perpendicular length between its bases. In a right prism, each lateral edge is perpendicular to both bases. A prism with lateral edges that are not perpendicular to bases is an oblique prism. You just kind of have to know this is a right, that's oblique. You all of that vocab up there. Don't really need to know the technicalities there. Just if you see a right prism, you should be able to identify it. If you see an oblique prism, you should be able to identify that as well. So I got some things X'd out from the book. The book wants you to do this formula. I don't like it. It's in the book. You'll see it if you look in the book. I don't think that that's a smart idea. I think it's smarter or better just to find the area of each one of the shapes. So when I'm looking at this here, I see I see 5 rectangles, and I see 2 pentagons, and they happen to be regular pentagons, and it says pentagon. Okay, so here we go. 9 times 7.05, and then there's 5 of those. So this is going to be the lateral area, and they might simply say find the lateral area. If they do, that's all you need to do. But we're going to add the bases plus the bases. We've got to do lateral area plus bases, and there's 2 bases. Okay, so now what we need to do is we need to find the area of this regular pentagon. Well, we learned how to do this in chapter 11. Okay, so what I see here is this. See a triangle. See the radius is 6. If I take 7.05 and divide that by 2, because I'm going to draw the apothem right here. So 7.05 divided by 2, 3.525. Now I could find the apothem, which is what I need. So what I'm going to do is the Pythagorean theorem, 6 squared, and then I'm going to take away 3.525 squared, and then I'm going to square root that number. And so what I'm getting for the apothem, after I'm done with the Pythagorean theorem, is 4.8 so 4.86. And now I can do 1/2 times apothem times perimeter, and the perimeter is 7.05 times 5, 35.25. Now there's 2 of these, so I'm going to do 2 times this, because there's 2 bases, so that just gets rid of that, and I can add 4.86 times the 35.25, and 171.32, and just add those 2 together, and then you have your surface area. So there you go. That's an example. And then we have cylinders. Basically, we have a circle on the top, we have a circle on the bottom. Those are the bases. And then you have the lateral area again. Okay, this is our lateral area right there. It's the area that goes around. We're going to add 2 circles, and we're going to add a rectangle. Okay, now again, the formula in the book is, they're going to give you that weird, nice formula there. We don't really need that. I don't like it. Just add the 2 circles. So pi r squared plus pi r squared, that's 2 pi r squared, plus the lateral area. And now the lateral area is kind of interesting. And this is something I can show that's easier to show in person than it is to show via video. So you're just going to have to go with this 2 pi r h. Where it comes from is if you unfold if you like cut a slit there and then you unfold it, it makes a rectangle. This length right here is 2 pi r. And the reason why it's 2 pi r is because if you wrap that around, it goes around the circle, it's the circumference of the circle. So you have 2 pi r times the height, and that's where 2 pi r h comes from. So that being said, let's just give this a try here. You're wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical with height of 1.2 millimeters and radius of 60 millimeters. What is the minimum amount of shrink wrap to cover the 20 discs? Okay, so we have 20 discs, and each one is 1.2 millimeters. So what I'm going to do is I'm going to find the height. So 20 times 1.2, that's 24. So the height is 24. And then they give us the radius. Radius of 60. Okay, so the radius is 60. Okay, so what we're going to do is we're going to do 2 pi r squared. And you might think, well, isn't it like a combination of like circumference and area? Yeah, it is. But what we're doing here is we're doing area times 2. Okay, so we have the circle on the top, circle on the bottom. Now the radius is 60, so I should probably just put 2 times 60 squared is 3600 pi. This is the 2 bases. Plus, now we're going to do, 2 pi r h. 2 pi r h. So 2 times pi times radius times height, and put that in your calculator. That's your answer. Alright, find the height of the right cylinder shown, which has a surface area of 157.08 square meters. This is a problem where you have to work backwards. You're going to use some algebra. So I have 157.08, that's the surface area, equals 2 pi radius squared. So these are the 2 circles on the top and the bottom, plus 2 pi r, which was 2.5, times h. We're going to solve this for h. So what I'm going to do is I'm going to subtract this number right here off on both sides, whatever that number is. And I'm just going to type that in my calculator. So I'm going to do 157.08, take away 2 pi times 2.5 squared. And that gives me 117.81 equals, I'm going to do 2 times 2.5 and get 5 pi times h. Okay, and then I'm just going to divide by 5 pi to get h by itself. And just remember, when you're doing this, make sure that goes in parentheses. So divided by, in parentheses, 2 pi. That will give us our final answer. H equals 18.7500. There you go. So that's working backwards using algebra to find a missing value. Here's your assignment. All the questions are pretty similar. I threw some questions on here that I think that you guys will like. If you want a little bit more of a challenge, give those a try. Otherwise, there you go. That's surface area. Thanks guys for tuning in. Appreciate it.